everyone, it's really good to see you all. So as you all know, data structures are the foundation of efficient programming. They come in various types, each serving a unique purpose. So in this video, we'll explore different data structures, understanding their characteristics and discuss when to use each of one. So let's get started. Firstly, let's start with the basics, primitive data types. So these are the fundamental data types directly supported by programming language like integers, floats, characters and booleans. They represent single value and are the building blocks for more complex structures. Next up, we have arrays. So arrays are ordered collection of elements, each identified by an index or a key. They offer quick access to elements, making them suitable for tasks that involve frequent indexing or searching. Moving on to linked lists, unlike arrays, linked lists don't require contiguous memories. Elements are connected via pointers, allowing for dynamic sizing and easy insertion or deletion. Singly linked, doubly linked, or circular linked lists offer variation to suit different needs. Now let's stack up our knowledge with stacks. So stacks follows the last in first out LIFO principle. Elements are added or removed from the same and making them ideal for tasks like managing function calls, undo operations, or passing expressions. Now let's talk about queues. So queues on the other hand adhere to the first in first out FIFO principle. Elements are added at one end and removed from the other, mimicking a real-world queue. Queues are commonly used in scenarios such as task scheduling and breadth-first search algorithms. Now, let's branch out into trees. So trees are hierarchical structures with a root, branches and leaves. They are used for tasks like representing hierarchical relationships, organizing data hierarchy and implementing search algorithms. Binary tree, avial tree and B-tree are just a few examples. Now, connecting the dots with graphs. So graph represents relationship between entities with node and edges. They are versatile, used in various applications like social networks, maps and network routing algorithms. Directed, undirected, weighted and unweighted graphs offer flexibility in modeling different scenarios. Lastly, let's hash out hash tables. So hash table use a hash function to map keys to indices, providing fast access to values. They are efficient for tasks like implementing dictionaries, caches and databases. Now let's recap. So to recap, we have covered a spectrum of data structures today: primitive data types, array, linked list, stack, queues, trees, graphs and hash tables. Each has its strength and use cases, and choosing the right one depending on the specific requirement of your programming task is the key to your mastery in coding. So this is it for this video. I hope this helps. Please do like, share and subscribe to the channel. Thanks for watching. I'll see you in the next one.